Hello, this is Samir Chatterjee from Ribaka Technologies. I have my colleague Debayan.
Hello, everyone.
We are going to discuss about RIC and the importance of RIC in an ORAN architecture. So, to start with, Devan, when we talk of ORAN, what's the first thing that comes to your mind?
Okay. The first thing, split LAN architecture, separation of radio unit from the processing units, multi-vendor solution, general purpose hardware, software dominant.
Split RAN and software dominant, multi-vendor, all this seems like lots of different vendors bringing their solution together that used to come from a single RAN vendor. So it seems complicated and a lot of challenges. So how does that actually translate into any real value in terms of application or service for the operators or the end users?
Good observation and a good question. Like this is supposed to be more beneficial to operators, but in reality, the interoperability challenges and the complications of multi-vendor solution deployment, they act as a big deterrence to ORAN adoption.
But there is so much buzz about ORAN and how the distributed RAN architecture is going to truly take advantage of the RAN components and enable us to provide services better, faster, cheaper. And then you're talking about the challenges. So, what in the ORAN architecture is bringing that ability that enables us to provide the value?
Well, I would say it is the RIC, the RAN Intelligent Controller, because the ability to efficiently use the radio resources while monitoring the radio components and dynamically orchestrating those resources is the primary value addition of ORAN, and this functionality is enabled by the RIC.
Great observation. Actually, if you kind of look back and kind of look at over the years, the most of the innovations has been focused around the packet code. If you look at the network slice, if you look at the service-based architecture or the control plane, data plane separation, none of these really enabled us to take advantage of the radio network any more efficiently than we have been used to. And then when you look at a mobile network, the heart of the mobile network is the radio.
Right.
And then if you look at the cost, the RAN, the radio access part of it is most expensive and is very complicated.
True.
Right? Don't you agree that? So it is only very recently with the ORAN and the RIC coming into the picture, it has enabled the operators to optimally manage the radio components and provide a better service to the customers and use the resources optimally, so that the total cost of ownership of the radio equipment is best utilized and value is delivered.
So it becomes a win-win situation for the operator and the end user.
Right. The RIC, as you can see in this particular diagram, is you have the two pieces, the non-real time and the real-time RIC. Now, the non-real-time RIC is within the SMO, and it is used to control and optimize the RAN resources. It uses AI/ML models that are trained to provide policy-based guided kind of decision making through these applications that run on a non-real-time framework called RAPs. And in case of near real-time RIC, what it does is it enables us to take real-time control and optimization decisions on the RAN by measuring fine-grained data collection from the RAN components using the E2 interface and then provide actions against it that are guided through this applications deployed in this real-time, non-real-time framework called XApps. The difference between the non-real-time and the real-time, near real-time RIC architecture is the timings. In case of non-real time, the control loop is in the order of seconds, whereas in case of real time or near real time, the control loop works in the order of milliseconds. Now, this combination of real-time and non-real-time RIC architecture, the framework, and the XApps and the RApps are the key elements of ORAN architecture and enables us to optimally utilize the RAN and deploy applications, provide application-specific decision-making logics, and a lot more that we will dive into. I think that to best analyze this.
So as like Samir nicely mentioned, the combination of the non-real-time RIC and the near real-time RIC and XApps and RApps. So this is one of the use cases which we have recently worked on, the RAN slice SLA assurance. And the overall objective of this use case is to make sure that the user experience can be optimized for a particular slice, even when the RAN resources are optimized. So the user experience can be met, the SLA can be met with the optimal RAN resources. That is the overall objective. Now, let me first introduce the different components in this this exercise. So we have the Juniper RIC, which is basically the platform on which the XApps are deployed. The particular XApp, the primary actor here is the Intelligent RAN Slicing Manager, which is shown on the left, which is from Intel.
That's the XApp.
That's the XApp. And that contains different components, the RAN metric predictor, the traffic load predictor, and importantly, the radio resource planning component. And then on the southbound interface, in the lower half of the image, you can see the Rebecca E2 sim, which simulates the E2 node. So since this is a test and simulation environment, and in real life this would be replaced by a DU and or a CU. So the overall call flow is such that once you initiate or you install the XApp, then the XApp subscribes to specific measurement data or KPMs, as we say, in which is going to help it to perform the intelligent radio resource planning. So some of the KPIs which are passed on to the XApp, which the XApp subscribes to and which the E2 simulator passes it on to it, are like the radio resource utilization, the average UV throughput, the packet latency, packet drop rate. So all these are an indication of the utilization and the data or the traffic volume of particular slice over a period of time. These get passed on to the XApp processes them, and it has its internal AI and ML engine to apply the different models which are loaded into it. And based on that processing, it can predict the load in the near future. And based on that prediction, the radio resource planning unit comes up with a slicing configuration, an optimal slicing configuration, which you can see on the right, which is also known as the RRM policy or the radio resource manager policy, which has like some amount of dedicated resources plus the prioritized resources plus the shared resources. So it's a guidance, it's a policy guidance to the DU, which gets pushed down through the E2 interface. So as you can see, it is an automated feedback loop. On one hand, the KPM data or the fine-grained data, which is continuously passed on from the E2 node to the XApp, and then the XApp taking its decision by applying its logic, and then pushing back a control signal to the DU, which then realigns its radio resources based on that guidance, and that helps it to sort of optimize the resources without violating or without breaking the SLA, which is mandated for that slice. So this is the overall use case, which runs in an automated and a continuous manner. Thank you.
Thanks. And this is a blueprint that we have developed jointly with our partners, and we are working on this. Similar to this, the slice related use case that Devan went in, network security is another use case that we are working on. It's a very critical aspect of 5G and ORAN, particularly because it's a disaggregated, virtualized environment where components, network functions are deployed in a distributed manner. We have started working on an initiative with Johns Hopkins Applied Physics Lab on doing network security related threat analysis, detection, and model development for the core side. and we are just started to look at on the ORAN side. And that's a very important element because it's the access network. And now that, as you can see, you have these.
First point of attack.
It's the first point of attack. And Devant, what would be your approach in terms of going after this particular use case as we have started working?
Sure. So the approach here would be probably a little different from the approach we took while trying to detect the similar threat on the core network. Because in the RAN, since we may be dealing with a lot of traffic, so we would be like one of the approaches that we have thought of now is to go with the statistics or the statistical information of the control plane and data plane traffic per interval of time, because the whole architecture of the XApp is such that it enables the nodes to send data at a very frequent interval to the XApp. So during this interval, what if we could send the relevant statistics like the RRC packet counts, the mass packet counts, the MAC packet counts, and the user plane throughput on a per UE basis. So this is some of the sample information which, if there is an attack, there is going to be some anomaly in these counts which will be easily detected since this is being observed on a per interval basis. And based on that, the relevant XApp can then send an alert back to the node through an E2 control signal. And once it gets the control signal, the E2 node can decide to block the particular UE or the group of UEs, whichever is appropriate. So that would be the overall approach.
That's creative, and I think what this whole RIC framework allows is such creative development of XApps and RApps from the application community in general, very much like an app environment. There are a whole bunch of other use cases that the ORAN work group requirement has specified. There could be a lot more. Traffic steering for optimal RAN resource utilization and user experience is one critical element. Context-based dynamic handover management for V2X is obviously a very critical use case for autonomous vehicles. Massive MIMO beamforming optimization, radio network energy optimization. We talk about green revolution, trying to optimally identify how to utilize RAN resources and accordingly shut them and then hand off users is a very critical element.
There are two aspects of this radio network energy optimization. One is the network optimization itself, which will result in definite cost saving for the operator. And another more difficult but even a more innovative scenario could be to reduce the power on the UEs themselves. So there are ways of detecting that a UE has a good enough CQI value, so we could reduce its power without impacting the user experience. So that would result in a more holistic energy saving mechanism, both on the network side as well as the UE side.
There could be a number of other use cases related to ORAN, and we covered a couple of them in details. And as ORAN and this RIC framework with XApps and RApps are taken advantage of by the operators and they deploy the blueprints, we would see a lot more interesting use cases than some of the ones that we touched on. I'm sure you agree with that.
Right.
And I think what we'd also see is, in my opinion, as the adoption increases, because RIC is a framework where XApps and RApps kind of get deployed, we would see something very much like an app in what we see in the mobile industry.
So a wider participation of the application community.
Right. So which kind of goes back to the initial question that I had, and where you said lots of different hardware and software. Yes, there is going to be a lot of different challenges related to interoperability, making sure we're testing and being able to test these blueprints thoroughly is going to be very critical before they deploy, right?
Right. So I guess there would also be similar kind of simulators that come in to help test these blueprints.
Sure. I'm sure we'll see that. We have a white paper on this whole topic where we discuss some of the use cases that we touched on. and how one would go about implement them. Please download and enjoy reading it. Thank you very much.